This is our wind generation kit, and it's based on this wind turbine. It's got a stick or a stalk that can be used in a retort stand. There's gearing here, so we've got one that turns much faster and one that turns slower. If you put the power straight into this one, you'll get a higher speed. This one, you've got to turn it more in order to get the same effect. With that wind generator, you get kit. This is from Stellar, by the way, STELR, and this kit fits together. And so that's your propellers, and you have a variety of blades, several of this type, several of the smallest type, and the blue ones, which are a variant in between the red and the yellow. Okay, you've got the area here, so the kids can work out what area of fan blade. This one says 30 centimeters squared, so that whole blade covers an area of 30 centimeters squared. And you basically open this and put blades, and I'm just going to put two in opposite places, and they lock together, and you have different angles that you can try, and students can measure the angle looking at that, the plane of that against that. So I'm about 45 at the moment. I'm just going to put one opposite. So we've got two blades, and students will have to work out, if you put this one at 45 degrees, what angle do you need to put this one at to be most efficient? Do you need to face it with this part at the back or at the front? How many blades do you want to use? Is it just two? As you know, most wind towers have 3 blades. Is 4 better than 3? There's a whole range of experiments you can do. This is designed to test students' ability to investigate. We're just going to do a basic one like this and see what happens. If your blade is very heavy, you might want to use the gearing, so it'll spin more quickly but give you less revolutions of the generator. Your generator comes with cables. The back here, doesn't matter which ones you use on which side, you just might get a negative voltage when you're doing your measurements. So that's our generator. And here we have, each kit comes with a voltmeter. I'll just make sure this one works. And we want it on DC. And we're going to plug our generator into it. So common is black usually. And we want to measure the voltage. So we're going to go on this side. It automatically adjusts to millivolts and volts. We haven't figured out how to keep it on volts. So students will need to work out and transform between millivolts, which it is showing now, and volts. It's automatic DC, and you can actually hold. If your voltage is varying wildly, you can do some holds and take averages of the readings. So that's our voltmeter. We're going to put our setup on a retort stand. As part of the STEM values, we've had students design their own wind turbine towers from a variety of sources. So you just need to make sure that you've got the lesson fully prepared and you're ready to go. If I start turning this, you're getting a voltage already, and it's a millivoltage because it's not. If you go faster, it might transfer over to volts. There you go. You can see when at various points now it's in volts. So 0.4. If I go the other way, you'll get the positive voltage. Okay, there's an enormous amount of value in this kit. The things that students can work out, from surface area to number of blades to size of blades. You can add up the surface area, change the value of angles. So there's a lot of numeracy also. Test rig kit that you can power through. You can see if you can power a particular lamp, LEDs. It's got 2 different colors. You've also got a buzzer that you can use. And you can show the kids how that's been wired up. There's resistors in there and all sorts of things that you can explain. Our black common, and then we have our red cable from here going into these. You can also take voltages across these different devices using the voltmeter and get some values there. So we've turned on the voltmeter. We have just a small fan here, but basically we'll be using large industrial fans, very safe with very tight cages so students can't put their fingers in. You need to watch things like blades, make sure they're not putting those into the fan. Also, we've got our safety certification, and we want to keep the cables far away from the fan as possible. It is a metal fan, but it's always safe to just keep cables away. You never know what students might accidentally do. Now, it's not at the right height, but we'll get an idea when we turn this on if we're going to get some movement of our fan. Okay, so here you can see the fan's blowing around, turning. We did an experiment with Year 9 that involved a variety of things, but the distance from the fan giving us our different values for wind with different designs. So we had a ruler, meter ruler at the bottom, and we measured the distance to the fan blade, the center of the fan blade or the edge of the fan blade, to our propellers in order to get a distance. So we're getting a voltage here. So it's sitting at around 2, 3. Once again, you can hold to give you a constant value. Take some averages of that. Another average, this is millivolts. And once again, we're working out how to keep it in of just volts. Okay, maybe 4 or 5 values, and then take the average of those. So the numeracy details are fantastic. We've also our variety of fan speeds that you could adjust. So once again, we're concentrating on the variables in experiments. If I change one variable, what happens? What voltage do I get? If I change another variable, the blade pitch, the number of blades, the gearing on the generator. So enormous value, enormous potential for a variety of different tasks, but it also helps students remember quite easily that this is a renewable type of energy. Whenever there's wind, you've got electricity being produced. Enormously valuable, and it's the questions that come while the kids are doing this work that is just priceless. And I can't speak highly enough. That's sold to us by Stella, ST. You can see it up there. Stella wind generator on the Stella website. Thank you. And you just see some of the other things in the kits that we've got. Spare blades, so you can have students working on 2 different prop designs. Something to take the voltage across lamps and other devices. A variety of blades, and we have a certain number per set. And a little instruction booklet for our voltmeter. Amazing stuff. We've kept things in kits, and we've got labels that are going onto the front of the kits with little pictures to show all the equipment that's supplied. Okay, I hope that's useful for you, and you can see the variety of science worksheets and things that we've got developing for next year's junior program. Thank you very much.